I am going to explain about the concept of feedback. Here, feedback is defined as the process of returning the fraction of the output, that is part of the output of a system or a circuit to the input in order to minimize the error. This block diagram shows the basic concept of feedback. Here the input is coming from the source that is given to the normal amplifier with gain A. The fraction of the amplified output is given to the feedback network. The feedback output is again added with the input. This feedback signal may be either in phase with the input or out of phase with the input. Depending upon in phase and out of phase, there are two types of feedback: positive feedback and negative feedback. Positive feedback. If the feedback signal is in phase with the input, it is called positive feedback, so that the amplifier gain is increased and often the output is distorted and the circuit starts oscillates. The gain of the positive feedback is given by AF is equal to A by 1 minus A beta, where A is the gain of the amplifier, beta is the feedback ratio, AF is the gain with feedback. Negative feedback. It is defined as if the feedback signal is out of phase with the input. So, the amplifier gain is reduced and the output is improved, that is the stabilization in gain is obtained. Here the gain with feedback is defined as AF is equal to A by 1 plus A beta. So, in both the cases, if the value of, for example, in positive feedback, if the value of A beta is equal to 1, then AF is equal to A by 0. In negative feedback, if A beta is equal to minus 1, then AF is equal to A by 0, which means that gain is nothing but the ratio of output to input. So, in both the cases, if modulus of A beta is equal to 1, then AF is equal to A by 0, which means that we are getting the output without applying any external input signal. So, the circuit becomes oscillator. These are the important characteristics of negative feedback. Because of negative feedback in amplifier circuit, it has higher input impedance, lower output impedance, stabilization in voltage gain, improved frequency response, more linear operation, reduced noise and distortion. In negative feedback, the feedback signal can be connected in four ways. They are voltage series feedback, voltage shunt feedback, current series feedback and current shunt feedback. Here the voltage means connecting output voltage as input to the feedback network. Current means tapping some output current through the feedback network. Series refers to connecting feedback signal in series with the input signal voltage. Shunt refers to connecting feedback signal in series with the input current source. Voltage series feedback. It is defined as the fraction of the output signal voltage is fed back in series with input signal voltage. This is also called as voltage amplifier. Here the gain A is equal to V0 by Vs. Voltage shunt feedback. Here the fraction of the output signal voltage is fed back in shunt with the input current source. This is also called as trans resistance amplifier. Here the gain A is defined as V0 by Is. Current series feedback. Here the fraction of the output current is sampled and it is given as the input to the feedback circuit. That is, the fraction of the current is converted into a proportional voltage and then given as input signal. This is also called transconductance amplifier. Here the gain A is equal to I0 by Vs. The last type of feedback is current shunt feedback. Here the fraction of the output current is fed back in parallel with the input current. This is also called current amplifier. The gain A is equal to I0 by Is. Thank you.